Hi. Let's look at some consecutive integers. Alright, let's start up 2. Next one's 3, 4, 5, and so on. What is the pattern between these consecutive integers? Well, let's see. From 2 to 3, how does it get there? Well, it's adding 1. From 3 to 4, we add another 1. And you'll see the pattern is adding 1 for consecutive integer problems. Well, that's great if we have a starting point and we know we start at 2. But what if we don't start at 2? What if we start at n, okay? And n could be any number. N is a variable in this case. Well, if the first number is n, what is the next number? Well, if we know the pattern is plus 1, we can add 1 to n. The next one should be n plus 1. Alright? And number after that, well, the pattern is still the same. I'm going to add another 1 to it. Alright, so it'll be n plus 1 plus another 1. So we'll get n plus 2. And the one after that will be n plus 3, and so on. Okay? So that's the pattern for consecutive integer problems. Now let's look at consecutive even integers. Okay. Let's start off with, let's say 4 is an even number. The one after that is going to be 6 and 8 and so on. Okay. So let's look at the pattern between consecutive even integers. Well, from 2 to 6. Well, we're not jumping up by 1 anymore. We're actually jumping up by 2. And from 6 to 8, we're going up by another 2. And the pattern repeats by adding 2. So when we have a variable, let's say c, right, we know the next even integer must be 2 more than c. So it'll be c plus 2. And the next even integer after that will be c plus 4. Right, and so on. And lastly, I want to look at odd integers. These are all consecutive odd integers. Start up with, let's say, 7. Right, next one will be 9. One after that is going to be 11. So what happens here? Okay. How does 7 go to 9? Well, we're still jumping up by 2. And from 9 to 11 is 2 again. And it's actually the same pattern as even integers. So if we're starting with the variable a, the next one will be a plus 2. It'll be a plus 4. Okay? So the pattern is actually the same from even and odd integers. And the reason why is because to go from one number to the next number, we're going up by 2. Are we adding 2 to the previous numbers? Okay, so let's take a look at a word problem over here and try to work this out. Okay, it says find 3 consecutive integers whose sum is 45, right? So we know we're talking about 3 numbers. The first number, second number, and third number, right? And the sum is 45. That means if I'm adding the first number, right, plus the second number, plus the third number, I'll get 45. Well, what is the first, second, third? Well, that's the question. Okay, so let's the first number, let's make it into a variable. Let's make it n. Right, the next one, if it's consecutive integers, must be n plus 1, one more than the previous. And third number must be n plus 2, right? So when we're adding these numbers, well, the first number we just replace with n. And we're going to add the second number, n plus 1. Third number is n plus 2, right? If we add up all 3 numbers, it should be equivalent to 45. Now let's solve for n. We'll be adding the n's on the left side. We have 3 n's plus 3 equals 45. Right? And we subtract 3 from both sides. Get 3n equals 42. we can divide by 3, divide by 3. N is equivalent to 14. Right. And if n is 14, I mean the first number is 14, the next one must be 15, and the third one will be 16. And those are your 3 consecutive numbers that adds up to 45. Okay. Let's take a look at this problem over here. Find 3 consecutive odd integers whose sum is 63. Okay, the key word here is odd. Right? So we're looking for 3 numbers again. I normally like to create a legend on the left side, and this tells me which each number is, right? Okay, let's make it n again. So the next odd number must be n plus 2 this time. Okay, remember odd number skips by 2. And the third number must be n plus 4. Now let's write them together and add them together. And this should be equivalent to 63. And we solve for n. Again, we have 3 n's we're adding, so it would be 3n plus 6 equals 63. Right? Subtract 6 from both sides, and you get 3n equals 57 divided by 3. You will get n equals 19. And if n equals 19, the next odd number will be 21. The one after that will be 23. Okay? Another way you can get it, just substitute 19 for n, and you will get the numbers. Okay? This one actually goes over here. Alright. Next, let's go try this problem on the bottom here. 13. The sum of the first and the last of 4 consecutive integers is 33. Find the sum of all 4 numbers. Right? So this time we have 4 numbers. First number, let's make it a little different, make a C. C. Next one, because they're consecutive integers, next one must be C plus 1. Right? And C plus 2, C plus 3. Okay. Be careful with this one because it's not talking about the sum of all the numbers. It's talking about the sum of the first and the last of the 4 numbers. So we're not going to use every single number here. We're just going to use the first one and the last one. And it says this, and the problem tells us to add both of them together. So it'll be C plus, right, C plus 3 equals 33. Add up the C's, we get 2C plus 3 equals 33. Subtract 3 from both sides, we get 2C equals 30. Right? Divided by 2, C is therefore equal to 15. Okay. So C is 15. Next number after that will be 16, then 17, then 18. And again, the question is a little tricky. It says find the sum of all 4 numbers. So I need to add all these up to get the final answer. And if you add up all 4 numbers, it should be 66. Okay, and that is the final answer. Okay. Hope this video helps a little. But good luck with math. Okay? Enjoy and have fun.